doing the code coverage for that. Okay, so we'll see one by one. So what is an arbiter? So we know that the basic fundamental of an arbiter, right? Arbiter is a basic it is a block that will take the request from the different masters, and it will process those requests from the it will process those requests from the master, and based on that it will give you the grant, right? This is the function of the arbiter. So uh, this functionality you can achieve with any of the algorithm, right? So there are many algorithm by which you can achieve this functionality, right? So one of the arbiter algorithm is round robin, other is fixed priority based scheme, bus access to the master. So these are the two techniques they have shown in order to implement the arbiter, right? So they are telling a particular scheme can be programmed as required. So based on the application, like what application you are having, right? If you always go want to give the higher priority for the processor, during that time you have to go with the fixed priority algorithms, right? Round robin algorithm is used suppose in cases where suppose two master is there. Once you have given request grant to one master, next time you should not give the request to the grant to the same master. Next time you have to give the grant to the next master. So this is equally distributed, so request grant is given equally to all the masters in case of round robin algorithms. Okay, but it depends based on the algorithms we have, based on the application we have to use the arbiter algorithms. Okay, so these are, they have shown one arbiter block diagram, right? So in this arbiter block diagram you see one request signal is there, right? So this request is a 2-bit signal. Okay, then they are having a b size is there, bus size. Okay, then they are having d select, then they have write whether b clock, and then reset signal is there. So basically we should don't we no need to consider other signals, just concentrate on request, grant, and clock and reset. Okay, so these are the 4 major signals till now required in order to implement an arbiter. Okay, so what they are trying to say, the requesting master generate a bus request signal on a request line connected to it. So from here you will get request. So how many? This is 2-bit, right? So 2 masters, you can use 2 master can drive this signal, drive this port. Okay, upon detecting the bus request, the arbiter grants the bus to the requesting master as per the priority scheme programmed. So then arbiter will process this request, from it will check which master has given the request, based on that it will give the grant. So basically problem will come during the time when both the masters are asking a request, both the master is looking for the bus access. Okay, so both will assert the request. So at that time your arbiter should be good enough in order to select between the select which master is having higher priority, and based that it has to give the grant. Okay, so problems usually you will find many bugs during that time when two resources want to access the same thing. Okay, so during that time you will find maximum bugs. So the arbiter indicates the grant to the master by asserting a grant signal connected to the requesting bus master. So a grant, so this is an output signal from the arbiter, and this will act as an input signal to the masters, 2 masters suppose you are having. So you will get 2 different 2-bit signals. Okay, so the master acquires the bus and perform the data transfer. After that it will perform the data transfer. Okay, so this is the normal functionality of the arbiter. Okay, now we'll see one by one the pin description. What is the use of pin? So a request, we know that this signal is a input to the arbiter, and this signal is given by the masters who want to access the bus. Now a grant is there. A grant is a signal that will act as a output signal from the arbiter. So that output signal will tell to the master that at this time you can access the bus. Okay, input control line, b write. So read or write line generated by the current bus master. So suppose one master is there. Okay, that master want to write or read. How you will come to know whether your master want to write or read? So during that time b write will come, tell that you master want to write inside the write into the slave. Okay, so 0 for read and 1 for write. B size, number of bytes indicated by the current master. So B size, so you can say that is a burst also. how much data your master want to transmit towards the slave. Then you have to use B clock. So this is the bus clock signal line. This is the active low reset line. D cell is slave select line. Okay, this is the, you can say that you are having multiple slaves, right? So which slave you need to select at what time, this D cell will tell. Okay, at this time you select this slave. This master want to communicate with first slave or second slave, so D cell will tell that. BD is a bidirectional data bus. Okay, so this is the objective of data bus. Okay, now input output controls lines are there. Okay, so B wait, so these are some of the control signal. B wait, signal generated by the selected device requesting wait state insertion. So you can suppose you can insert wait states also. Okay, inside your device. You can say you take example, suppose your slave is there, right? So slave is not ready to give you the data. Okay, in that case what you can do, your slave will insert some wait state inside on the bus. Okay, so during that time arbiter what it will do, during that time that master will not transmit the data on that. Okay, so B last data transfer indication signal. So this is the last data transfer indication signal. B error, bus error indication signal. So if there is any error on the bus, you will get this signal is getting asserted. Okay, so actually basically these signals, this arbiter they have implemented for AHB, no,